All right, this is a video for Monday, Algebra 2. So we're in day 3. And so notice the learning question that it asks, how do we find inverses? Well, when they give you one function and they say find the inverse of, here are the 2 steps. You swap the x and the y, swap the places, and then you solve the resulting equation for y. Okay? So write those 2 steps down, and those are the 2 steps. Now, inverse functions are the reverse of each other. The x and the y values are switched. All right, so right away on number 1, they want you to graph each point. Okay, so graph 1, 2. 1, 2 is right there. Graph -1, 1, right there. Graph -3, 0, right here. And graph 5, 1, right there. And then graph its inverse. So the inverse of 1, 2 is to switch them, 2, 1. So there's 1, 2, there's 2, 1. -1, 1, there's -1, 1, there's 1, -1. There's -3, 0, there's 0, -3. There's 5, 1, there's 1, 5. All right? What do you notice about the original points with their inverted points? They're reflected across this line, which is y equals x line. And so that's what's kind of cool about inverses. The points of the original function and their inverted points will reflect over that line. Okay? So, as we continue on, for number 2, it says, given f of x equals 3x and g of x equals 1/3 x, evaluate. So, I'm just going through these. They want me to take 3, put it into the f function, so 3 times 3 is 9, and then take 9 and put it into the g function, which is 1/3 of whatever the x value is. So I take that 9 and put it here. So 1/3 times 9 spits out a 3. All right? Take a 2, put it into the f function. So what's the f function? 3 times x. So 3 times 2 is 6. Take that 6 and put it into the g function, which is 1/3 times x, which now is 6, right? So 1/3 times 6 spits out a 2. All right? G of f of 4. So I take a 4 and I put it into the f function. So 3 times 4 is 12. I take that 12 and I put it into the g function for the x. So 1/3 times now 12 spits out a 4. F of x. So simply take this 3x and put it into the g function. So 3x is going right there. 3x is in the parentheses right next to the 1/3. So when I do that math, what's 1/3 times 3x? X. Now switch them around and go f of g of x. So take the g function and put the 1/3 x right there where that x is. So 3 times 1/3 x. And when you do that quick little multiplication, it spits out an x. All right? So, what I want to show you is I'm going to plug these 2 functions into the graphing calculator. All right? So I'm turning on my graphing calculator. I go to y equals, clear out what I have, clear out whatever. All right, so I'm putting 3x into the first y equals. I'm going to scroll down, and now I'm going to put in 1/3 x. So I'm going to put a parentheses 1 divided by 3 close the parentheses, x, okay? And when I hit graph, there's the 3x, there's the 1/3 x, all right? And it looks very similar, to what I had earlier on the graph above. Okay, now, what I want to do is I want to look at the table. So I'm going to hit second and table. So notice something. When x is -1, the f function in blue is -3. All right? And when x is 0, when x is 0, the f function is 0. When x is 1, the f function is 3. When x is 3, the f function is 9. So I just made that table from this table. Now, I look at the g function. Notice the g function. That's in red. All right? When x is -1, the g function is a -1/3. When x is 0, the g function is 0. When x is 1, the g function is a +1/3. When x is 3, the g function is 1. All right, so there's those tables. Straight from my calculator. All right? All right, so what do we notice about these tables? The f of x and the g of x are reciprocals, basically. All right? Also, you'll notice that whatever the f of x does, the g of x does the opposite, or it undoes it. All right? So, -3, -1/3. +3, +1/3. Okay? This here, +9, but then we get 1 there, so I'm wondering if that's supposed to be 0.1 or not. All right? How are f of x and g of x related to each other? They're inverses. Okay? So, if we take the f of this f to the -1 here. Oh, let me move the paper a little bit. All right? This f of -1 is the symbol for inverse of x. So make sure that you don't read that f to the -1. You simply read that as f inverse of x. Okay? F inverse of x. So, down here at the bottom, it asks us to write each function and its inverse using just symbols. So, when it says add 3 to a number x, f of x is going to be x plus 3. The inverse of that is to do the opposite. What undoes x plus 3 to go x minus 3? All right? Multiply a number x by 4 and add 5. So 4 times an x and then plus 5 is the f function. Now, to undo it, we have to subtract a 5 and then divide by 4. So notice x subtracting a 5, and then that is divided by 4. So we're undoing the multiplying of 4 and the adding of 5. Okay? When you square a number x, you get the f function is x squared. What undoes a square, is to square root. All right? All right, so that's kind of how functions and inverses are related to each other. All right? As we continue on. Once again, the 2 steps. To find an inverse of another one is to swap x and y and then to solve for y. So for instance, I show you here, if we're given the function y equals 2x plus 4, and I want to find the inverse of that, all right, I'm going to put the x, I'm going to swap the x and the y. So x equals 2y plus 4. Now move the 4 by subtraction. So you have 2y equals x minus 4. I show it right there. Now to solve for y, divide by 2, divide by 2. So y is by itself, x minus 4 all over 2, so separate them. X over 2 is like saying 1/2 x, because there's an invisible 1 right there. So 1/2 x, and then 4 over 2 is minus 2. So y equals 1/2 x minus 2 is the inverse function of y equals 2x plus 4. All right? All right, let's do what number 4 asks us to do. Number 4 asks us to find the equation of the inverse of x. So that's what I just did. I took y, see, f of x is a funky way of saying y. Y equals 2x plus 4. I swapped the x and the y, and I proceeded to solve for y. So that is the inverse of x, 1/2 x minus 2. All right? So they picked some values for us. So when x is negative 4, this is the f function. Put a negative 4 right here. 2 times negative 4 is negative 8. Negative 8 plus 4 is negative 4. Take a negative 3. 2 times negative 3 is negative 6. Negative 6 plus 4 is negative 2. Negative 2. 2 times negative 2 is negative 4. Negative 4 plus 4 is Zippo. 2 times a negative 1 is negative 2. Negative 2 plus 4 is a positive 2. Put a 0 in there. 2 times 0 is 0 plus 4 is 4. And so on. So when x was these numbers, f of x are these numbers. All right? Now take the same x numbers and put them into your inverse. So when x is negative 4, so 1/2 times a negative 4 is negative 2. Negative 2 minus 2 is negative 4. Put a negative 2 in for x. 1/2 of a negative 2 is a negative 1. Negative 1 minus 2 spits out a negative 3. Plug a 0 in for x. A half of 0, right? 1/2 times 0 is 0 minus 2 spits out a negative 2. Put in a 2. 1/2 of 2 is 1. 1 minus 2 is negative 1. Put in a 4. 1/2 of 4 is 2. 2 minus 2 is Zippo. When you put in a 6, it spits out a 1. When you put in an 8, it spits out a 2. So then I graphed these points. All right? And here's what's really cool. I'm graphing the f function points and the inverse points. All right? And that's what you see right here. Negative 4 is right here. Negative 3, negative 2 is right here. Negative 2, 0 is right here. Negative 1, 2, 0, 4, 1, 6, 2, 8. So it's kind of like a straight line. All right? Then I plugged in the inverse functions. Negative 4, negative 4. Negative 2, negative 3. 0, negative 2 is right here in red. 2, negative 1 is right here. 4, 0. 6, 1. 8, 2. What do you notice? The x and y values have switched. All right? See here? When you come over to the inverse function, instead of negative 3, negative 2, it's negative 2, negative 3. Instead of negative 2, 0, it's 0, negative 2. Instead of negative 1, 2, it's 2, negative 1. Instead of 0, 4, it's 4, 0. So what you can see is on the graph, they're reflected over this y equals x dashed line. All right? And that's what happens. On a graph, a function and its inverse will reflect over this diagonal line that goes through the origin and splits quadrant 1 and quadrant 3 right in half. Where do the two graphs intersect? Right here at -4, -4. All right? So if the graph of a function, and its inverse intersect each other, the intersection will always be wherever y equals x. It will be on that dashed line somewhere. All right? So, continuing on, some ways to determine if f of x and g of x are inverses. Numerically, you can make a table of values for the f function and use the y values in the f of x table as the x values for g of x. In other words, the x and the y columns in the first chart should be switched in the second chart. And that's what I showed right here in this table. How that the x and the y values in the f function, when you look at the inverse function of f, they have swapped places. The x's are in the y spot and the y's are in the x's spot. Okay? The second thing that you can do to determine if functions are inverses graphically is graph the f of x function, graph the g of x function on the same graph. All right? And look for symmetry across that y equals x line. Okay? And then algebraically, which is what we're going to show you now, is take the f of g of x and do the math if it comes out to be equal to x, and then you switch the functions and go g of f of x, and you do the math there, and it comes out to be x. Then you have found out that those are inverses of each other. So down here at the bottom, I want to show you how to do that. Okay? I'm going to show you algebraically. Here it is. So we're going to take f of g of x and g of f of x. All right? So I take the g function, 1/2 x minus 2, and I am going to put it into the f function. So this right here is going to go in place of that x. So 2 parentheses, this whole parentheses is where that x is. So 2 times the 1/2 x minus 2 plus the 4. Okay? So quickly I do my math. 2 times 1/2 x is x. 2 times the -2 is -4, and then I have that plus 4. So x minus 4 plus 4, poof, those undo each other. You simply get x. Now I'm going to reverse the order. All right? So g of f of x. Take the f function, take this here, and put it into the g function right there for the x. Okay, so 1/2 parentheses. In that parentheses, you're going to put the f function, 2x plus 4. And then don't forget there's a minus 2 at the end of that g function. So the quick little math, 1/2 times 2x is x. 1/2 times 4 is 2. And then you have the minus 2 at the end. So guess what? The plus 2 minus 2 undo each other. You're left with x. When f of g of x equals x and g of f of x equals x, that proves that they are inverses of each other. All right? Continuing on. All right, this time they want us to find the equation of the inverse of x. So here's my math. The 2 steps. Plug a y, or take the x and the y and switch them. So notice, f of x is a funky way of saying y. So y equals x squared minus 4. Swap the x and the y. So that x goes here, that y goes there. So x equals y squared minus 4. Move and then solve for y. So add the 4 over here. So y squared now is by itself equals x plus 4. To undo a square, you square root both sides. And you get a plus. So when you square root both sides, don't forget you get a plus minus symbol. So the inverse of f, function is a plus minus square root of x plus 4. And there's where I wrote that. Okay? So Make a table for each equation. So I'm picking certain numbers that, like here, I just picked 0, 1, 2, and 3. So when I put a 0 in here, 0 squared is 0, minus 4 is negative 4. 1 squared is 1, minus 4 is negative 3. 2 squared is 4, minus 4 is 0. Plug a 3 in, 3 squared is 9, minus 4 is 5. Okay? So since I know that this is an inverse function, all I have to do is swap these. Take the y values, put them over on the x side, take the x values, put them on the y side. And so that's what I did right there. So the inverse function has negative 4, 0, negative 3, 1, 0, 2, and 5, 3. So when I graph those points, okay, the original f function is 0, negative 4, 1, negative 3, 2, 0, 3, 5. So I kind of made that little curve there, okay? When you swap them, the inverse of f function is negative 4, 0, negative 3, 1, 0, 2, and 5, 3. And sure enough, those two graphs are symmetrical around the y equals x line. Ain't that kind of cool? I think so. So what's the domain? All right. The domain, they gave us the domain here. X greater than or equal to 0. All right. So what's the range? Look at your range. The first value is negative 4 and it goes up. So y is greater than or equal to negative 4. Over here, what's the domain? Well, we're keeping the same. Well, the domain is our x value, right? Negative 4, and the x's go up. So x is greater than or equal to negative 4. And the range, y is greater than or equal to 0. What do you notice? The domain and the range swapped. Okay? The domain x greater than or equal to 0 is the range, so that's y greater than or equal to 0. The range of the original f function was y greater than or equal to negative 4. That becomes the domain of, so x greater than or equal to negative 4. So the tables, if you were to look at the tables, the columns switched. All right? Those columns there got flipped over into the inverse function. What do you notice about the domain and the range? They also switched. Okay? And then what do you notice about the graph of f of x and the inverse of f functions? They are symmetrical around the y equals x line. They reflected over that. Now, where do the two graphs intersect? Approximately at 2.56, 2.56. So about 2.5, 2.5. Now, I don't know if I can see that or not on my graph. I'm going to graph this. Okay. So let me clear this out, see if we can figure that out. X squared minus 4 is the f function. X squared minus 4. And then the inverse is the square root of x plus 4. All right. So there's the two functions. I hit graph. So there's the blue. No. Yeah. No. Go back to y equals. X squared minus 4 and the square root of x plus 4. But our domain is only, yeah. I can't really do it into the graphing calculator because the domain was only supposed to be greater than or equal to 4. Oh well, not sure what happened. All right, moving on. 2.56, 2.56 roughly is where these two intersect, about 2.5 and 2.5. Okay, now it does say here, and I'm going to have to do a little bit more research on this. To use a graphing calculator to check the graphs for each function, press the following buttons in order to graph the first equation. So you press the y1 equals parentheses x squared minus 4, close the parentheses, and then x second test, hit the number 4, and then put a 0 in. So I'm just going to see what happens. All right. So y1 equals, I'm going to put parentheses, x squared minus 4, x square it, minus 4. It's close the parenthesis, start a new parenthesis, hit X, hit second, and test is right here. See, test in blue, so I hit that, the math button. Then I hit the fourth one down, enter, and I put 0, and I guess I close the parenthesis, and what? I hit graph, I guess, maybe? So I'm not sure if I'm doing it right or not, so we'll have to figure that out at another time. All right, let's move on. Number 7, find the equation of the inverse. All right, so here I am. That's y equals x cubed plus 2. So I swap the x and the y. So now x equals y cubed plus 2. Move the 2 away from the y cubed because now we're supposed to solve for y, so I subtract. So y cubed is by itself. It equals x minus 2. How do I undo a cube? Cube root and cube root. So y now is by itself, so I'm going to write it as f of negative 1, or the inverse of f, equals the cube root of x minus 2. And that is the inverse function of x. The cube root of x minus 2. Okay? All right, so when I plug in some numbers, they gave us these numbers. A negative 2 into the f function, negative 2 cubed, is 8. Negative 8 plus 2 is negative 6. Negative 1 cubed is negative 1 plus 2 is 1. 0 cubed is 0 plus 2 is 2. 1 cubed is 1 plus 2 is 3. 2 cubed is 8 plus 2 is 10. So those points are over here on the graph. Negative 2, negative 6. Negative 1, 1, 0, 2, 1, 3, 2, 10. So it makes this funky curve right there. All right? Then, since I already know these are inverses, just swap the columns. So instead of negative 6 in the right column, put negative 6 in the left column. And instead of negative 2 in the left, put it in the right. So negative 6, negative 2, 1, negative 1, 2, 0, 3, 1, 10, 2. And those are down here. Okay? So sure enough, they're reflected over the y equals x line. The domain, it goes forever to the left, it goes forever to the right. The domain, the range goes down forever and up forever because there was no restrictions. All right? And here, the domain, all real numbers, the range, all real numbers. What do you notice about the tables? They're switched. What do you notice about the domain and the range? They're all the same. What do you notice about the graph of f of x and the inverse of f function? They are reflected. Okay? They're reflected. And approximately where these points are intersecting, about right there, is at -1.5, -1.5 roughly. All right? All right, we're almost done. Last little bit right here. They want us to find the inverse. All right? So, here's how we're going to do this. That's y equals 2 over x plus 3. So, swap the x and the y. So now the y is going down in the denominator, the x is going out front. There it is. X equals 2 over y plus 3. All right? Solve for y. So move this 3 by subtraction over to this side. That now cancels that out. I'm left with 2 over y equals x minus 3. I have to get y up in the numerator, so I'm going to multiply by y and multiply by y. That moves it upstairs into a numerator, so that cancels out. So y is multiplied with this x minus 3. Okay, right there. So how do I get that x minus 3 moved away from y? Because my goal is to get y by itself. So, since it's up here being multiplied to y, I divide by x minus 3 and divide by x minus 3. That will cancel that out, so y is now by itself. What? Y equals, there's a 2 over x minus 3. And so that is the inverse of that function. All right? Here is number 9. Take this function, y equals 3 over x plus 2. Swap x and y. So x goes here, y goes there. So x equals 3 over y plus 2. In this case, I need to get the y upstairs, so I'm going to first multiply both sides by y plus 2 and y plus 2. That cancels that out. All right, so now I just have y plus 2 times x equal to 3. So now I need to move the x away from y plus 2, so I divide by x and divide by x. And so now I have y plus 2 equal to 3 over x. All right, y plus 2 equals 3 over x. Get the 2 moved away from y by subtracting it and subtracting it. Y is now by itself, and it equals 3 over x minus 2. And that's how you apply those two steps. Swap x and y, and then solve for y. All right, that is the lesson, and it took 33 minutes. Definitely you want to get practice at this because we're going to have a quiz on Friday. All right, quiz on Friday. So this is day 3. We want to get, day 4 on Tuesday, and then we'll spend a couple days reviewing and then have a quiz hopefully on Friday. So you really do need to practice this homework, all right? And if you're at home quarantined or sick or whatever, we miss you, but you need to stay up to date, all right? Peace out.